So I'll not go into how to identify that you must have studied already in your drill standard. And then we are having something called as a variable resistor. So it's an adjustable resistance, or typically called as a potentiometer or a pot or a short. Okay. So this is how it looks like. So you'll be having three terminals over here. Sorry for the disturbance. Now we'll come back to our discussion. So in this case, you will be having three different terminals. I hope one can see it, or you must have used it also. So if you connect between two, then it will act as a variable, or if you connect between the other two, then it will act as a constant. Right. So any of the combination you have to consider. So in order to get that, you will be having a knob here which you have to rotate. Okay. So based upon the rotation, the value of the resistance will change. Anyone has used it? Maybe in their build standard or any other laboratory?
Potentiometer, sir?
Yes.
Yes, sir.
Okay, the best example is something which is there for your fan regulator. It also works in the same way. Okay, so if you open, you will find in the same sort of thing it is there. It's not the exact replica of this, but it is somewhat based upon this principle. Sometimes it depends upon what kind of model you are looking. Okay, so it generally the smaller one which is there nowadays of the switch size, basically having the resistances of different values. Right. So now there is two different kinds of fan regulators you will be using. One is with the step, and one is without step, right? So it's just a knob which rotates without any step. So that is again a kind of potentiometer, and the other one is with the steps. I think you are able to connect with. So step means you will be having different resistances connected to it, right? So if you open it, really you will find that different values of resistance are connected, and the sound which you are getting, so it is basically shifting from one place to another and looking for the other resistance. In this way it looks like. You can simply open any bad regulator is there in your home, then you can open and you can check them also. Or else you just Google it, you will find it. Okay, now coming to this next part, the short and open circuit. A device with zero resistance is called as a short circuit. A device with zero conductance is called open circuit. So zero conductance means infinite resistance is your open circuit. Now we have to understand when you are shorting something, okay, when you are making the short connection, this is for the short, this is for open. So when you are shorting the terminal A and B, obviously you will expect a current to flow in this loop. It is forming a loop. Obviously it will form a loop because you are having some network here, and the output terminals here, let us say some sources is also there. And when you are shorting this A and B, obviously the current will try to flow from here, and the resistance will become zero for that, right? And the potential difference between terminal A and terminal B becomes zero, because both are having same potential, and the current will start flowing through. So whenever there is a short circuit, there flows the current. And if you see here, whenever there is an open circuit, there is a voltage but no current. There is no current here, whereas there is infinite resistance here. Is that okay? Are you able to understand this point? Is it fine? Is it okay?
Yes, sir.
So the best example to understand it, why I am telling you always the example from the household is because you are sitting there and you can actually connect with what I'm trying to explain or discuss. Right? So let us again take the example of what is there in your home. Most probably something like this. The socket you will be having something like this. So this is what is the ground, and generally if this side your switch is, then this will be the phase, and that is what is the neutral. So what I am trying to explain is, see, when the current is flowing, that means you are getting the household supply, and you have not connected any device or appliances. That means if you switch on this button or the switch and you have not connected it to any appliances, and if you take a multimeter and check the potential difference between these 2 points, okay, multimeter or voltmeter. So obviously you will be getting 220 volts. Is that fine? Are you able to understand this, what I am saying? If your switch is at on state and no appliances is connected to your socket, right? And if you take a multimeter, put the red one to the phase and the black one to the neutral, obviously you will be able to see the voltage, which is 220 volts. Now at this time, what is the resistance? The resistance is infinite. Why it is infinite? Because the points or the terminals are open. You have not connected anything. Please understand. At the same moment, you can say that there is no current flow. Fine, there is no current flow here when it is open, just nothing is there. As soon as if you take a piece of wire, let us understand in this way. Don't do this. Okay, it is very hazardous to just you think, and you will be able to understand what I am saying. Let us assume that you have taken a piece of wire. A piece of wire you have taken and you have connected from here to here. And you have put the switch in on state. What will happen now? These two will get short circuit. Obviously, either this will get fused. What are the implications? Let us first understand. What are the hazardous implications? Either this will get fused, or a very high power it will dissipate and it will burn, or if the triplet circuit is good in your household, then it will get tripped. Okay, but what happened in the shortest duration? What you will find is, for a short duration of time, the current flowed from this terminal to this, okay, and you can say that the resistance is zero because you have connected direct wire. And what is the potential difference between this point and this point? The potential difference becomes now zero. So is that okay? Are you able to understand what is happening now? Basically, this case goes with this. So, draw it here. Basically, it will happen here. Okay. When you are connecting directly a wire and putting the switch in the on state, so this is what you are expected, that the current will flow in the very short duration and immediately your supply line will get tripped. Okay, but what exactly happened there? There is no potential difference. There is a short circuit. Currents try to flow from one point to other point. The potential difference between the point A and point B becomes zero, and the resistance also will become zero. Okay, so that is why you are supposed not to touch the open wire, because it will try to complete the circuit and the current will flow from your body. Okay, please understand this. What is the implication of not touching it or touching it? You are not supposed to put your finger inside here, because whenever you are standing on the floor, you are basically grounding yourself, and the phase will try to move through your body, and you will be getting burn, or the current will flow through. Right. So that are all different cases. But what I am saying is, when you are shorting any two terminals, the current will flow, the voltage will become zero, and the resistance will become zero. But when you are opening two terminals, what basically happens? The current will become zero, the resistance will become infinite, and voltage will become a finite value. Is that okay? Now moving to the next part, the series parallel circuits. So whenever you are connecting the resistances in this way, that the other terminal of resistance is connected to the next terminal of the resistance, and so on in this fashion, then you will call this as the series combination. And if the terminal, let us say AB of the resistance R1 is connected to the AB respective terminals of the resistance R2 and so on in this fashion, then you will call it as a parallel connection. And this is called as a series connection. So what is the implication of having parallel and series connection? First of all, the current in case of series connections remains same. Okay, the same amount of current will flow through all the resistances when you are connecting in series. Similarly, what is voltage? Voltage is the potential difference between 2 points. So look at here, you can see this point, this point, this point, and so on are all same, right? Hence, the voltage difference or the potential drop or the voltage drop between all the individual resistance will remain same, and it is what you are supplied, that is Vi. Right? So voltage will be same throughout the resistance. Whereas in this case, the current will be same throughout the resistance. Now, what is changing in that case? So, look at here, this voltage V1. V1 is equals to R1 into I1. V2 is R2 into I1 because the current is same. So, what is happening? The voltage is changing. If the resistance values are different, the voltage will change even though the current is same. And in this case, the current will differ even if the voltage is same because of the different resistances. So what will be the current in this case? It can be written as I1 is VR divided by R1. I2 can be written as VR divided by R2. Similarly, I3 can be written as VR divided by R3 and so on. So one more point you can think of, that in case of parallel combination, the current is different provided the resistances are different, and in case of series combination, the voltages will be different across the resistors. Even though the current is same, provided the resistances are different. Is that okay? Are you able to understand? Very simple, basic, everything must have studied. Is it fine? Is there any doubt here?
Yes, sir. Understood, sir.
Okay, somebody has asked for some question. Pavitra Shekhar, can't see the text. What is that? Siddharth has asked roll number 49. How the zero resistance happens? Where can, just now I saw your post. Can anyone, what is that question? If you ask the question for which point you have asked, then I'll try to explain it. Seems like it's not there. Somebody has written the text are not visible. Is it visible now? Can anyone comment here, please?
Sir, we can see the slides, sir.
Okay.
Sir, but your voice is not entirely clear, sir.
Yes, sir.
No, I cannot do now anything for that. I do not know why this is happening, because everything is fine, seems from my side.
Oh, sir, can you use headphones, sir?
Yeah,
Headphones
I
is
am
much
using headphone. I am using headphone. If you want, I can show that I am using headphone.
Sir, it's like little bit reverberating, sir.
Yes, sir.
Okay, okay. After this class, again, I'll try to bring another headphone and we'll have something. Okay, but I'll test it separately. Okay, maybe tomorrow's class we can do. But at this moment, I don't have because the one which I am having that does not have any mic. Okay. So, as you can see, I am having the headphone here for you. Okay, but I feel there is no doubt, at least, and because all these things you must have already studied, so there should not be any doubt in that. Now, again, the question goes to comes from here uh, how the switches or home appliances are connected in household, whether in parallel or in series. Can anyone quickly comment on that? It's very intuitive in nature. What I'm asking is,
Parallel, sir.
Parallel, sir.
anyone else? Can anyone explain why parallel? It's very obvious. I know everyone must be aware of that, but just to have the communication from both sides, you have to also contribute in the lecture. The answer is correct. It's the parallel connection because if you go for the series connection, the voltage will change, right? You don't want the different voltages. You want the constant voltages 220 volts, and hence it must be connected in parallel, right? So this is clear, I hope. And now we'll go to what is a very important point, that is the Kirchhoff's current law. Now, before starting with that, obviously Kirchhoff's, what you understand by Kirchhoff? It must be the name of that person. So yes, it's Gustav Robert Kirchhoff, by 1824 to 1887, a German physicist who stated two basic laws concerning the relationship between the current and voltages in an electric or electrical circuit. Now I have a question here. We have something called as law, and we have something called as a theorem. Can anyone quickly elaborate why there is Kirchhoff's law and why there is something like a Thevenin's theorem? What is the difference between a theorem and a law? In the subsequent section, we will be discussing about the Thevenin's theorem or Norton's theorem, substitution, Millman. But we are having something like KCL and KVL. Can anyone quickly tell me what is the difference between a law and a theorem?
Sir, law can be universal, whereas theorem can be for a specific problem.
Okay. Anyone else?
Sir, I'm not sure, but I think theorem does not have a proof, but then we have it, so it makes it easier to solve problems.
No, but generally for theorem, you will be asked to write a proof for that. Okay. In 12th or 11th also, they must have given a question. Okay, this is what the theorem, and you have to write the proof for it.
Yes, sir.
Sir, theorems are based on laws, but laws are not there.
The laws are based on what?
They
Theorems
are
can be
given.
changed.
Okay.
Laws are
Theorems
from
are applicable at
experimental
very
value.
few conditions, whereas laws can be applied anywhere.
Theorems can be changed later, sir.
Okay, fine. So I hope everyone is having a little idea about that. So I'll leave this portion to you. Okay, some stuff has to be there for you to also Google. And there is something called as a postulate also. Okay. In physics, you must have studied about something like the postulates. So you just go through what is the difference between the law theorem and the postulates. What you are saying that nearer to that, some answers you will be getting, but better to search it. Okay, what is the difference between the law and the theorem? So we will quickly come to our point. The algebraic sum of currents entering at a node in a closed or a closed boundary is zero. So that is what the KCL. The current entering a node may be regarded as a positive, while the current leaving at the node may be taken as a negative or vice versa. The KCL is based upon law of conservation of charge. This is very important point. This Kirchhoff's current law is based upon law of conservation of charge. And what it says, let us assume you are having a node here and different branches are connected to it, or different wires are connected to it. And assume you are giving some nomenclature to the current. Let us say this is I1, that's I2, I3, and I4. Then what it says, if you go for the algebraic sum of the current, then it comes out to be 0. So algebraic sum of current means what? You can say that if the current entering a node, let us consider that as a positive, and leaving a node, let us consider as a negative. Okay? Or vice versa. You can consider this as negative, but if you are considering entering as a negative, then other side you have to consider as a positive. Let us follow the statement at this point. Current entering a node is positive, while leaving a node may be taken as negative. Okay. So what you can say is this is positive, that's negative, that's positive again, and this is negative. So one can write it as I1 minus I2 plus I3 minus I4 is 0. Right? So this is what this Kirchhoff's current law says. And let us assume that you have to solve the circuit to determine the current flowing in this resistance R. Now this is the example in which we are having an independent source and the dependent source. Look at here how I have identified as a dependent source, because it is represented by the diamond symbol, right? So this is called as a dependent source. Now, if you take the algebraic sum at this node, okay? So this is a node in which the different branches are connected. So this is a current that is 44 milliamperes, which is entering the node. The direction of the current flowing in the resistance R is already mentioned to you, and it is outward. So this is Ix. This is also outwards, which is given by 10 times of Ix. So one can see here that the current value of this current source is dependent on the current which is flowing in this branch. Okay, and how it is connected? The branch current Ix is 10 times of the value of this current is 10 times of the branch current of this Ix, right? So this is how the dependent sources are written. And now let us apply the KCL. So one can write 44 milliamperes is equals to Ix plus 10 times of Ix. I hope this is clear to all. I have taken it the other side of equal sign. Otherwise, you could have started with the first Ix minus 10 times of Ix is 0. And then if you go for solving it, you can write Ix as 44 milli divided by 11, that is how much? So this is what the current flows in this branch, and similarly 10 times of this you can find the current value associated with this branch. Is it okay? This is how the KCL is used. And now the KVL, this already we have discussed in the previous lecture. It's the algebraic sum of voltage drops around any closed path. Okay, so summation V is 0. So how you can write it? As I told you, you have to start in a loop in this way. Let us say this is you, and you are started moving in this loop. Let us say in this direction, the direction which is given by this arrow. Okay, that is the clockwise direction. And always take the sign which is there at the entering point. So this is negative, that's positive, then positive again, negative, and then the positive, right? So one can write it as minus V1 plus V2 plus V3 minus V4 and plus V5, right? And then equal it to 0, and you can get some unknown values if most of them are given to you. Let us say in this case, so here you are standing, you started walking from this way, this is what your direction, okay? So you have encountered the minus 30 first, so minus 30 you will write, and then plus VR1, and then you are having negative 5, and then you are having positive VR2, Next is negative 15. Then positive VR3 is 0. So one can do a small analysis. Let us assume that you are having all the resistance values and the rest of the values are also given to you. You can easily find out the current flowing in this loop. Okay. Let us assume this is 10 and this is also 10 ohms. Then you can find out the current in this case. So how you can write the current equation in this case to find out the current in here? So you can write minus 30 plus 10 times the I1 or current I which is flowing in that resistance minus 5. Let us assume this is also 10 ohm resistance plus 10 ohms into current, that is I, then minus 15 and then plus 10 into. Okay. So if you solve this, obviously there is one linear equation, so you will end up with some value of current. Okay. And here, if you go to the question, what is given in this question, assume that VR1 is 26 and VR2 is 14, one can easily comment on what is the VR3, right? So this is also one way to understand how the KVL and KCL works. Is that okay?
Yes, sir.
Now let us have some simple examples. I hope now one can solve it quickly. You are supposed to find out VAE and V VAE and VEC, okay, using KVL. So most of the values are given to you. There is nothing unknown. All the voltage drops are there. Even if the resistance values are not there, doesn't matter. So you can solve it. Okay. So as I told you, just remember this is the best way to remember it. You are standing here and you are moving in the loop in this way. Let us assume some direction. I always consider the first the clockwise. One can consider the anti-clockwise. There is no issue in that. And always consider the entering sign. Right? Now, you can start writing for it, but let us first understand what exactly you want. You want the potential difference between this point and this point. So either you can start from here to here, or you can write in this way also, the other way. That will be your VAE. So you start from VA point and reach up to VE. That's what your voltage. So VAE can be written as starting from VA. So you just write plus 16 and then minus 12 and then plus 4 and then plus 6. So this is what your VAE is. Can anyone quickly tell me what is this? I guess. Is that okay? Is that clear how we are calculating it? Basically, you can visualize in this way. Let us say you are having a multimeter and this circuit is available with you. And you are having two terminals. The one you are connecting at this point, and the other you are connecting at this point. So either you take the voltage from this portion, or you take the voltage from both are same. I hope this you are getting. If you are taking from the other side, considering 24 volts and this 10 volts, then VAE can be written as you are starting from this point and going in this way. So it is plus 24 and then minus 10, that is 14. Okay. I hope this is clear. Either way, either you go in this way, in the upside, or you go in the bottom way, right? In both the cases, we will be ending up with the same answer. Is that okay? Is that clear how we are solving it? Is there any doubt? Yes, please. Is it clear?
Yes, sir.
Yeah.
Yes,
And
sir.
what is the reason why magically it came as the same answer? One can ask this question, and the best answer is because it has to satisfy the KVL. And what KVL suggests? KVL suggests that in a closed loop, if you take all the voltages, it must leads to 0. If you go for the algebraic sum of all the voltages in a closed loop, it must leads to 0. So obviously all these values which are written here are satisfying the KVL, and hence if you take it in this way, rather I should just a moment, let me. Remove the annotations from here. Either you take it in this way, or you take it in the other way. In both the cases, it will give the same answer. Is that fine? So that is what I did. Now you have to tell me what is VCE. Please quickly tell me VCE. Oh, sorry, VEC.
18, sir.
Is that okay? VEC, whether it is 18?
I got minus 10, sir.
Yes, sir, minus 10.
Yes, sir.
Yes, sir, minus 10.
Yes, sir, minus 10.
Any other answer? It's minus 10, right? So it's not 18, it's minus 10. So I hope this is clear to everyone. Now you are able to understand the sign conventions also. And now very important aspect. What happens if I connect two different current sources in series? Can anyone quickly comment? If I, let us say, have 10 ampere and 15 ampere connected in series, what will be the current flowing in total? What is the total current? Can anyone quickly comment? If I connect a 10 ampere current source in series with a 15 ampere current source, what will be the total current? Don't look at the diagram which is there in the PPT already, just look at the question which I am asking. Can anyone quickly comment on that? Whether we will be getting 25 or we will be getting 10 or 15 or whatever. Yes, please.
Sir, I think two different currents cannot be flown in same line of a circuit.
What is your justification for that?
Sir, as we know, in any series circuit, basically only the current is constant. But here, if there are two different current sources, the current is not constant actually. Two different currents are existing here, sir.
Correct.
So that's why I think it's not possible.
Absolutely right. So this is a node. Okay. And as this is a law, all the circuits must satisfy this, right? So what KCL suggests you, if you take a node and you can write that entering current or currents are equal to the leading currents. Okay. But in this case, if I am taking a node here, two different sources, let us say 10 amperes and 15 amperes. So entering current is 10 and the leaving current is 15. So obviously such kind of connections are impossible. And you should not do such kind of connections. You will end up with burning all the sources. Nothing will work fine, right? So no two current sources can be connected directly in the series. Similarly, for the voltages also, you cannot connect a 1.5 ampere, 1.5 volts battery with 3 volts battery in this way, because either it will burn or it will damage or it will not work in a way you are thinking, right? So definitely it will not lead to, let us say 3 plus 1.5, you are arguing that you have connected to these two batteries, right? So what is the reason? Because it has to satisfy the KVL, and KVL suggests that in a closed loop, it should make it to 0. So in a closed loop, if you take it becomes minus 1.5 plus 3, which is basically 1.5, and hence it is not satisfying the KVL. So thus such kind of
Sir,
yes, please.
sir, if the voltage sources have internal resistance, then is it possible to have a parallel connection?
If they are having internal resistance, then that's a different case, right? Generally, we will consider whenever nothing is mentioned, it is the ideal sources.
Okay, sir.
If the internal resistance is there and they are little high, it's not negligible, then it can be connected, because they will come as series here and they will be having their own drop, and hence they will try to satisfy your KVL. But if it is an ideal source, you cannot connect it. Now, series and parallel equivalent of the circuit. I hope everyone understand and remembers it. If you can quickly tell me, we will skip this and we will go for good examples. What is the equivalent of such kind of series connected resistances? If I am standing here and looking into the circuit in this way, considering this is remote, then what is the equivalent resistance?
R1 plus R2 plus R3
Correct.
and so on Rn.
Correct. So this is how the resistances are. So I will not go into how this is coming. Does anyone require the proof of this? Does anyone require the proof of this?
No, sir.
Similarly, in case of parallel, if you remove, let us say this one, and stand here, look into the circuit, what will be the parallel combination? So R equivalent is 1 upon R1 plus 1 upon R2, and so on up to Rn, and it's inverse. Okay. So this is how the series parallel combinations are written.
So
And
1
now-
by R equivalent is equal to 1 by R1 plus and so on, right?
So what is an R equivalent? Look at here, please. This is what I kept inverse.
Yes, sir. Yes, sir.
Okay, now coming to the parallel resistors and the current division. So whenever you are connecting the resistances in parallel, the current will divide. Okay, because if the resistances are different, obviously current will divide even if the resistances are the same. And how it will divide? So that quickly we can identify, and such kind of is called as the current division or rule or the current division. So let us say you are having a voltage source V and two resistances R1 and R2 are connected, and the current which is coming out of this voltage source is I, and it is getting divided into two portions, that is I1 and I2, two components I1 and I2, that the I1 is flowing in R1 and I2 is flowing in R2. Then one can easily comment on what is the current value I1, what is the current value I2, and what is the current value I. So what you have to do is, you have to first of all find out the equivalent resistance here. So what is the equivalent resistance? These two are in parallel, so R1, R2 divided by R1 plus R2. So this is what the equivalent resistance, and now this circuit will look like this. You are having a voltage source V and the resistance R equivalent here and the current I. So one can write that V is equals to R equivalent into I, or I is equals to V upon R equivalent. Is that okay? And if the voltage value is there with you, the source value, so potential difference between these 2 points, and these 2 points, all are same because everything is connected with parallel combination and no resistances in these branches, okay, which I am highlighting here. And hence one can say that the voltage drop at this resistance R1 is also V, and voltage drop at this resistance R2 is also V. And thus you can write the current in this case as V is equals to I1 by, you can write the current here in this case as I1 is voltage divided by the resistance R1. Similarly, I2 is voltage divided by the resistance R2. And let us say if you write for the voltage value coming from here, so what is the R equivalent? Let us substitute this R equivalent here. This can be written as R1 R2 divided by R1 plus R2 into I, that is the total current. And substitute this V here in this equation in both. So one can write it here as I1 is R1 into R2 divided by R1 plus R2 into I am writing this equation here. I hope this is clear to what I am doing. And then this V you have written, and then there is a component that is 1 upon R1. So this will get cancelled out, and you will be ending with I1 is R2 into I divided by R1 plus R. Is that okay? Is it fine? Are you able to understand this?
Yes, sir.
Now one can have a shortcut to memorize it. And what is that shortcut? This is what is for I1. Similarly, one can figure out the current equation, I2 equation. So I2 can be written as R1 into total current I divided by R1 plus R2. So what is happening, if you see that when you are interested in knowing this current, you are taking the resistance in this other branch. Look at here, please. You are interested in current I1, but you are taking the numerator, the other branch resistance, and then multiplying with the total current, dividing by all the resistances. Similarly, when you are looking for this current, I2 current, you are taking the resistance from the other branch. Okay. Since it is only two branches, that's why only one values are coming. Let us assume that you are having more number of parallel branches, then their combination will come. But for just sake of simplicity, let us consider for the simplest case. So if you are interested in I2, you will be taking other branch resistance, total current divided by R1 plus R2. Let us say if you are interested in I1, then you will take the other branch resistance R2, multiplied with the total current divided by R1 and R2. Right? So this is how you can memorize for current. This is called as the current division rule. It's very intuitive in nature. One can need not to follow what I was discussing about a shortcut to memorize it. You can come up with your own idea of memorizing it, because it's a very important aspect. Whenever you are solving any circuit, this such kind of things are required very now and then, right? So you have to have all these things in your mind. Now a very simple exercise here. I want that you should come up with the answer. What is the R equivalent here?
Six ohms, sir.
Anyone else? Who has given this answer? May I know the name? Roll number?
Roll number 46.
This is 46 answer. Okay. Anyone else?
6 only, sir.
Yes, sir, 6, sir.
Yes, sir, 6.
62. What else? Who else?
34, sir.
34 is also 6. Okay. What else?
44.
6, sir.
44 also same.
Sir, 6 also. 6 only.
Sir, 6.
Sanjit, 43 also.
Sir.
6 only, sir.
Okay.
6 only, sir.
Fine, fine. Don't worry, I will not be writing for all the roll numbers. Okay, it's very difficult. But when you are giving such kind of answers, please make sure that you are able to justify it. Sometimes I may ask you to solve it here also. Okay. So it's very obvious. I will not go too much deep into this. I just will quickly finish this part. This is 4 plus 5 plus 3 that you have to do. And then whatever comes in parallel with this one, and series with this, whatever comes in parallel here, and then series with this one, right? So I hope everyone, if they have come up with the same answer, then let us take this as the correct answer, because I don't have correct answer for this. And then you are having another little complex. You are having some diagonal resistances here, but that they will not create too much problem in this case. So what you have to do is, this is 3 ohm, 3 kilo ohms, that's 1 kilo ohm, and then this is 6. So you will be having 6 in parallel with this 3. Whatever comes is in series with this 10. Whatever comes is now in parallel with this 6K. Whatever comes is in series with this. Finally, the parallel with this one, series with this, parallel with this, and series with this. Right. So this is how you can do. I hope this also you can solve. Please take a screenshot of this one. Yes, please go ahead.
Sir, can we do it by folding, sir?
How how you want to do? Can you explain?
Sir, like there is parallel folding and perpendicular folding. Here we'll, as it is symmetric, we'll fold it and consider that two resistance which are coming on each other as parallel.
You can use any one. You should end up with the correct answer.
Symmetry is not there, no.
Except for 2 kilo ohms, we'll
5
consider
kilo
rest as
ohms,
symmetrical.
This is for that's one. Exact symmetricity will not be getting solved. This. I think let us not complicate too much. Okay, let us do it in a very simple manner at this point of time, because it is only third lecture so far we have taken for the network theory. Obviously, we'll be getting too many places where you have to use your own shortcuts. Okay, don't worry. These are the questions which will not be asked in the examinations. Okay, don't worry. These are very simple, basics, and fundamental things. This is just again the revision. Because you are supposed to come up with all these basic aspects from the 12th standard. Okay, we will come to your the important parts, but these and all are very important because there is in your first unit. Don't worry, it's not like we are going out of the unit. It is there in your first unit, but I know everyone must have studied it, so they must have their own ways to solve such kind of circuits. Okay, you can use any method. I don't have any trouble as long as you are ending up with the correct answer. Now, in this case, you have to find out the current I. So current I, there are again the different methods you can solve. Maybe you can think of what is the voltage drop across these 2 points, and once the voltage drop is identified, you can the voltage across 30 ohm, and 30 ohm will be same. You can take that voltage value and divided by this 30 ohm, you will be getting current in this case, right? Or you can find out the current flowing in this branch and then use the current division. So I'm leaving this exercise again for you. You have to take the screenshot of that, and then in next class I will ask for the answers of this. Okay, that's it for today. We will see in the next class the star delta conversion with some other examples, and then we will go for some other a little one step higher circuits. That's it for today. Is there any doubt? Okay, thank you everyone.
Thank you, sir.
Thank you, sir.